Hello, Internet.
Today we're going to be talking about 3D rendering and OpenSimplexNoise. Um, so when you start out with 3D rendering, you have to basically define what 3D space is, like what's happening in 3D space. So when you're looking out the car window and your car is driving, how is everything moving relative to your head? What happens when you turn left and right, when you rotate your head? How do you do that without like rotating a camera? Um, And the answer to that is you want to rotate the world around the camera instead of rotating the camera around the world. So, for example, this is your vision circle, right? That's like what you can see. Sorry, that's a stupid term, vision circle. Um, so this is where you are, and this is like my fancy house over here. Now, how do I turn my head in this direction? How do I turn my head clockwise? And the answer to that is you just take this stuff and you rotate it the opposite direction. And you still draw, like let's say you're looking at this area right here. This is where you can see. You're always going to be able to see this one area, but what's going to happen is the world's going to rotate around the camera. Um, so that's what I mean by defining 3D space. So now the next problem you come to is, well, how do I take a 3D point, X, Y, Z, and turn it into like X, Y? And the answer to that is you can use a proportion to scale your Y value from a 2D down to a 1D, and you can use it from a 3D down to a 2D. If you check the GitHub link in the description, you can find the source code for a lot of the files that I reference, and you can see I have like relevant class down here and the name of the class. So if we go into the point 3D class, this is something that I made up. I mean, you know, and it basically holds X, Y, Z, and it's pretty simple. You can add to it, you can subtract, you can divide, you can multiply, you can get the distance to another point. You can rotate it around a point, like around by degrees, and you can convert it to a 2D coordinate, all like in this point class. So just reference that, take a look. So when you move into 3 dimensions, this is basically your field of view, and this first point over here, the first near plane, is going to be actually it's going to be like your virtual screen. So you're looking. Let's say this is at like x equals 10. So that's like what you're scaling everything to. You're moving everything onto that plane. So you're shrinking it. You're scaling it down. You're scaling it from, let's say this is 100, this far plane. This is 100 in Z. This plane is going to be 10 in Z. So you're just scaling it back by 10. The relevant class for that is the point 3D class as well, because that takes care of it. So what do we do now? So now we can kind of understand the concept of moving a 3D point to a 2D point, so you can see it on your screen. But that's great. Like you could draw points. That's not anything useful. So what I did was I made a cube class, I made a shape class, a pyramid class, and a face class. And these things all kind of work together. So we start off with the shape class, and in the shape class, what you've got is just like the bare minimum stuff, like how many sides the shape has, the points per side, and the amount of nodes. And then it holds like how the faces are put together and like all of that fun stuff. But we're not going to talk about that. So the pyramid is interesting. So it's got 5 sides. A cube, everybody knows how to make a cube. It's just, 1, 2, 3, 4. It's like 8 points. But anyway, so it's got 5 faces. Each node has 5 points. And, my bad. In general, there are 5 total points. And there are 4 points per side. And I use 4 points per side because the bottom's a square, and the sides are all triangles. And in this pyramid class, you can see how I label the indices of each point, and then I label the faces. And then if you look into that code, which is going to be in pyramid.class, it's also in the GitHub, you can really see how the faces are built and things like that. And oh yeah, if you notice, some of these points are the same. Like some of the faces share points, and I didn't handle that, so let's ignore that. So moving on to OpenSimplexNoise. OpenSimplexNoise generates basically a height map that kind of looks like this. It turns x, y, and x, y, and z coordinates into like just a number. So between -1 and 1. So that's really useful like when you want like hilly terrain and things like that. Um, so we're gonna pop in here. So what you're seeing is OpenSimplexNoise being used to generate a small height map, and the colors are just kind of like, oh, if it's -1, be kind of like an orangey color, and if it's above 0, like make it more green, I guess, and the middle's kind of blue. But what we're seeing here is you see like the hills that you would see here, and to generate like this kind of moving pattern, like you see like the camera's kind of like moving down this hill of things, there's only like a 10 by 10 grid of blocks, but every like 20 milliseconds it does like a tick and moves all the blocks slightly towards me, so it looks like I'm generating like more terrain, and then it moves the simplex noise generator like down the line, so you're seeing what looks to be movement, and it kind of is movement, but it's not, like the camera's not really moving. If you look at the top left next to the mini map, you can see my x, y, z coordinates, and you can see my x and z coordinates are not moving. The only thing that's moving is my y, because I'm going up and down, bobbing with the hills. So there's a lot to like dig into, and I figured this is gonna be like a good beginning discussion. So yeah, I'll catch you later. If you have any questions, comment,